we had common sense. We had empirical knowledge and empirical data that showed us things that's being overridden now by finite element analysis. But it's not finite element analysis. There's no way to ever get all the elements in that analysis. You think you have it, but you got to really dig through and figure it out.
I've been waiting a long time to get you one-on-one. It's been
I
a
know
while,
it
and
has.
I have you on. I have you. I've had you on the podcast a ton of times, and I think what people don't know, and what I want to share is that you are still, you've always been, but still kind of an ongoing mentor to me, and you tell me a lot of things that I don't want to hear, but I usually end up coming around and realizing that I should be listening to you because you tend to be right, and uh, and you have a lot of wisdom to share. But with that said, you're still super deep in the industry, and kind of ahead of what's going on today, but also what's coming. And, we've talked so much about energy codes and different building materials and different means of construction with prefab versus stick built, and what's driving decisions with union labors and overseas fabrication and tariffs and COVID
You
and
know,
blah, 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 blah. But, there's still an underlying theme that's always been super relevant to you and more prevalent ever today is energy codes. Um,
yes.
and something I talked to you a lot about the stretch energy codes in Boston, just because it's rather prevalent to me. I spent a good amount of time in that market. But you seem to think it's only a matter of time that some of that stuff comes to New York. I'm maybe a little skeptical just because of how slow things have been to adopt. But what do you see coming?
So we already have a stretch energy code in New York. It's the New York State Stretch Code. It's not as stringent, I would say, as the one up in Massachusetts, but it's pretty good. I am on the New York City Department of Buildings Energy Code Revision Committee, and it dictates a lot of the changes that or the tweaks that we want to make to the IECC, because maybe people don't know this, but every city and state right now is on some version of the international code, whether it's the IBC, the building code, or the IECC, the International Energy Conservation Code. Everyone's on their own version of those codes because it just became too expensive for a city like Boston or a city like New York to maintain their own building code. So the ICC, through volunteers, writes a master code like a template, and then everyone tweaks their own is the way it works. But then they take care of distribution and maintenance and legal reviews and the things that were costing us a lot of money. So I think there's a lot of harmony coming in the codes because of that. So you're going to see different people adopting different versions of the international code, and that's why people are on their own versions. Some are old. Some states are not ready to dive into, the stringency of air leakage or thermal performance of walls or thermal performance of windows that we're at in the current version of the code, which is understandable depending on climate. But yeah, there is. I think there's more harmony coming and there's more stringency coming everywhere. We have no choice. There's only so much energy that's available to us, unless we really kick nuclear and alternative energy into high gear. We're basically we're still on a carbon energy system, so we still burn hydrocarbons for our electric, for our heat, or at least the majority of our electric and heat are still coming from burning fossil fuels. So that being said, the idea is both from a financial perspective and a climate perspective to reduce how much how many hydrocarbons we burn because it's expensive both financially and to our future. And that is one of the things that I am really concentrating on right now. In addition to all the other work we do, we've been working on systems to help owners of buildings, operators of buildings be able to see where they're at so that they can plan how they upgrade their existing buildings to reduce their energy. And some of it's very simple is start with, how many people are in the building? Is the building 50% occupied? We're seeing a tremendous office to residential conversion market right now in the major cities. Post-COVID, office buildings were empty and they were still being heated and cooled and lights were still going on. And landlords had this tremendous cost to keep these buildings unoccupied and operating because even if only 20% of the people were in the building, they still had to run the building, right? Run the elevators and everything else. And I think that along with, demographics changing has uh, led to this office to condo conversion or office to resi conversion, which is a good thing. But what is a bad thing for me is they're in a rush to do it and they're not looking at this being the most opportune moment when they're already going to do some construction and they're already going to upgrade their facade. This is the time that they should be looking at making it the most efficient they can. Because we've done a lot of work on analyzing existing buildings, fenestration systems. We actually, about 5 years ago, maybe six, about a year or two before COVID, started developing a method for measuring U value of windows and R value of walls in situ, so on the building. And it's based on research that the Army Corps of Engineers did back in the early 80s. And there it wasn't really the right time to do it, but the Army Corps of Engineers is one of the largest real estate companies, believe it or not, or the US government, I should say, is one of the largest land and building owners in the world. And the Army owns a lot. Think about bases and housing and storage of vehicles. And by vehicles, I mean planes, tanks, everything. And then so they own a lot of property and they use a lot of energy. So the Army Corps of Engineers, believe it or not, has always been on the cutting edge of reducing their fuel consumption. And in the 80s, they came out with this method of measuring what's called heat flux. Well, they didn't come out with it, but they started applying it to buildings. And they did some really good research that's available for free online. The problem we had was sensor technology and computer technology wasn't advanced enough to make it a viable thing to do large scale. They basically used it as proof of concept to make some global changes to the way they were building buildings, but there wasn't a cost effective way of going out and using it to measure every building that they owned and see, where they were losing the energy. 40 years later, that stuff's all achievable, right? I have my phone has more computing power than the computers they were using back in the 80s that were mainframe computers. We've got more computing power and we have access to it. Access was a big problem they had back then too. It was access to the computers they could do it on. Sensor technology. So these are the ones that we build in house, which we do not do anymore because this thing cost me $2,000 to build in a barn. And today we've got a good alternative resource that will provide us really, really great sensors at a really, really good price, reliably. And we've been doing that now for the past 3 or 4 years and going out and testing ourselves, testing our system, testing our premises that, the premise that we used for how this is going to work and developing a system that we can hopefully in the very near future get to an affordable price and get it on uh, a system where people can easily access the technology that we've developed at a very low cost and then use it to help owners of buildings reduce their energy use. And the reason why I said before that when they're doing these office to residential conversions is the ideal time for that is because any window that's less than 40 years old, any curtain wall that's less than 40 years old, replacing it or even reglazing it sometimes only for the energy savings almost never pencils out economically. It's a big thing that I think is getting lost in a lot of the carbon reduction and energy efficiency messaging that's out there is that you can't justify the cost of replacing glazing systems, especially, but it applies to regular buildings too. The disruption to insulate a 50 or 60-year-old building that doesn't have any insulation in it is enormous unless you've already emptied out the building because there were no tenants and offices and you're going to convert it to condominiums. Now is the time to really insulate the walls, replace the windows or curtain wall with a really high performing product because you've already budgeted enough money to upgrade it because you need to upgrade it to get it repositioned is a word that we use a lot, repositioning these buildings. Now is that's the really, unless there's money incentivizing you to do it, it's the only way to make that case that you should go to super high performance stuff. Does that make sense?
Of course. Of course. I think I'm trying to think of what to extract from what you said, but I think what's really important is
It was
the word
one long run-on sentence.
the dissertation, the what you said about accessibility, and I've actually been playing with this glass modeling software that lets you input all your different stresses and snow loads and negative and positive wind loads and look at different compositions and understand where there's going to be stress and max deflection and so forth. And that, stuff like that in the past was such like tribal hidden knowledge that, one guy in, I don't want to mention names of companies, but who I'm like, a window company, one guy within that company, he has that software and you got to go to him to run a deflection analysis, or you got to go to him to run a therm.
Yep.
And do you think, not yet, but we're heading in a direction where gone are those days where this stuff is going to be easily accessible to everybody, and all of a sudden you can run therms, you can do heat flow analysis to understand, or just to gain more awareness?
We're committed to physical measurements rather than modeling. Um, so Therm is the standard for North America. That's the program we use. People refer to it as NFRC modeling, but it's really an NFRC version of a therm or window model, right? It's with the NFRC boundary conditions and everything else, but it's a therm model. Therm was developed right around the time that the Army Corps of Engineers was messing with these sensors, right? 40 years ago. And really the last 10 years, there haven't been many system upgrades to Therm. There's been library upgrades, some patches. We have a couple of certified modelers in house, and they curse it all the time because just as they're finishing something, it crashes. They lose all the work. It's just it's time for an upgrade to Therm, but right now there's no money for that. The Department of Energy does not have any plans for it. The national labs don't really have any plans that I know of to make a replacement for therm. There are some European ones, but what I'm excited about is, like you mentioned, you can do that analysis today in pretty much all the 3D CAD software has the ability to do this. Um, Thermal analysis, you can do that in just about all the goods, there's CAD software now to a degree, right? You can get pretty close to real life if you put the time into it. The thing is, it takes a lot of time, and even using AI tools, it's still a time-consuming thing to do. But if you're a manufacturer and you're willing to put the time in to put your catalog into whichever version of CAD they're using, um, I think it's worthwhile because while Therm is and was always meant to make sure that consumers are protected, basically. So an NFRC model is not for you to go, which is a huge issue right now, is not meant for you to go and do an energy loss analysis on a building. Could you use Therm to do that? You could. It's a tremendous undertaking to do that. You literally have to model every size window on the job. You have to use secondary software to model it hourly based on weather data. It becomes a real ex- overly expensive process to do on and use Therm to model a building's energy loss. If you have let's say, a university that really wants to know what can I expect from a replacement high performance curtain wall, let's say with thin triple glazing or regular triple, double OE triple glazing or vacuum insulating glass. A manufacturer today does have the tools to give them real analysis. Now, they will get scientific numbers from the CAD software and then have to convert them into energy units, but it's doable. It's doable. What we've tried to do is uncomplicate that and account for the as-built conditions, so to speak, the in situ conditions of that window and that opening, no matter what the surrounding construction is. We're not doing probes and destructive analysis to see what the profiles of the windows are, the makeup of the walls, all that stuff. We're just putting these sensors all over the walls and the windows and saying, okay, here's the heat that's flowing through it. I don't really care why it's flowing one way rather than the other. I just want to measure when it's cold outside and warm inside and we have heat being driven one direction. This is how that specimen is performing, whether it's a brick wall, a window. We want to just see in real life, under real conditions, how much energy are we losing through that wall. And unfortunately, this doesn't fit into some of the high performance energy programs that are out there. And I'm not going to mention any of those names, but they've all been set up with great intentions, and they've been set up again to make it possible for an engineering or architectural practitioner who's not necessarily well versed in kilowatts or watts or flux of heat and K values and everything that goes to the basics, but they needed to give them tools to say, you will be able to build an energy efficient building if you do this. And that's what most of the programs that are out there now, like LEED and FIAS and all the rest of them, are basically tools for a person that's designing a building to have a way of analyzing how a building can best perform efficiently. Now, that's really good for new construction. But when you have an existing building, you have to know where the starting line is to be able to figure out how to get to the finish line.
Have you used these resources or tools on new construction and existing buildings?
So we've used our system on both types of buildings. It's not the shortcoming of the products necessarily, it's the gaps within every metric. So we call it U value of a window, right? But if you really look at what NFRC calls it, they call it U factor. It gets back to what I said before. The NFRC was created so that consumers walking into Home Depot and looking at an Anderson window and a Pella window and looking at the labels, and one says U.40 and the other one says U.40, a consumer needs to know they're going to perform the same. They don't need to know what the .40 means other than good, better, best, excellent, but they need to be
Where
able
am
to
I
know that
spending my dollar and what am I
where am
getting
I
out of it?
and am I getting something? It's the same with insulation. Before the 1970s, insulation did not have the R value, the concept of R value did not exist 60 years ago. Any insulation manufacturer could make whatever claims they wanted for the performance of their product. And the FTC, the Federal Trade Commission, actually said we need a standard that people can walk into, again, Lowe's, I won't use Home Depot this time, into Lowe's and see Owens Corning and compare it to North Insulation and say that one's R20, that one's R20. They will perform the same for blocking the heat loss through my walls. And that's how our value came about. It was the Federal Trade Commission saying we need to make sure that we protect the consumer. And that's where these numbers came from. Now, they are not suitable for high level analysis of whether or not your building is going to lose X number of kilowatts or watts or BTUs or therms through the walls. They're just not. There's a huge gap between what those numbers were meant for and what they're being used for now in the building energy modeling software that uses them under the assumption that they mean something, because I don't think you can go online and find anything that says U value and U factor are not the same thing. Anywhere you look on the internet,
Yeah, it's going to be a post that you and I did or something, me
right?
referencing you. So
it-
what I wanted to get to before is when either utilizing this in existing buildings or new construction, what has surprised you? Or what is an assumption you make going in where you've really changed your mind or perspective on it?
So it's not so much in the measurement. So we know what a brick wall does. We know concrete, brick, stone, they have pretty bad U and R values, right? But I think I've posted this on LinkedIn a few times. they're like sponges, right? You have a brick wall that's 4 wide. There's a lot of mass there. And although that mass is very bad at resisting the flow of heat, it's really good at absorbing it and storing it for a while. So this is something people talked about for forever, and built using those concepts. Innately, people understood the brick will heat up and then it'll slowly cool down. The thing is, once it's saturated, so once you have a cold night that's 30 degrees Fahrenheit, let's say, and it's 30 degrees Fahrenheit for 4 or 5 hours, if there was no heat on the inside, or there was heat on the inside, but the cold is colder than the colder it is outside, the faster it happens, obviously. But once that masonry surface reaches saturation, the sponge gets absorbs all the water dripping out of that faucet. Every drip that falls into the sponge falls out of the bottom of that sponge. It's putting a sponge in your sink over the drain and having drips, drip, 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 drip. Eventually, the sponge just gets totally saturated, and every single drip that goes in comes out. Might take an hour for that to happen. And that's the surprising thing to me, is how well people who built buildings 100 years ago understood this. And you had Joe Stiebrick on one of your previous podcasts. I learned this from him. He has his whole, we used to build buildings out of rocks, and now we stopped building buildings out of rocks. And why we built it out of rocks was not just for the how how durable it was, but also because it has that latent ability to absorb the heat and give it off slowly. So what surprised me is that even though the U value we measure on, let's say we did 1 Center Street, it's the main office building for New York City, right? We did that, and it's a massive wall, and I mean mass. It's 10-inch of stone and 4 inches terracotta. It's a mass wall. How well it did in the modeling, because when we applied the hourly weather data to what we had measured, it turns out that the energy loss through the wall wasn't as bad as we were expecting it to be. Because what we've tried to do is take these simple measurements, right? I mean, simple in the way of we develop a number and then apply it to a yearly weather model, not really using traditional modeling like people think of, but it's a calculator, right? We do hourly or minute by minute weather, and then we see what the delta T is. So the outside air temperature versus standard buildings are usually heated between 68 Fahrenheit and 72 Fahrenheit. So a pretty constant 70 inside and a varying weather temperature outside. And it turns out that this actually works better than we thought it would. Now, it doesn't mean you shouldn't insulate brick walls. You absolutely should insulate brick walls. And no matter what that woofy model, again, something I learned from Joe, no matter what that woofy model says, just don't go crazy with it. And even if the dew point line does move into inboard of where you want it a little bit, it's still in the middle of a piece of brick, and it's only the theoretical dew point. And maybe the amount of times that that dew point is moving on the inboard side of the wall or towards the inboard side of the wall, because there's still some people who don't believe it can ever move to the inside of the building. Whether or not that is actually hurting you from an energy perspective is really debatable. It really is. A lot of people think that. We've done so many buildings that people thought were having moisture problems on the interior because of dew point, and it turns out almost always it's bulk water entry through physical defects in the wall.
When you have people make these comments or chime in, and then you see, okay, are they a envelope consultant, thermal modeler, or Kermel contractor? It usually influences the way they're talking or the way they're viewing the project. But more so, I feel like the climate they come from or geography they come from so much so skews the way or their outlook on a certain means or methodology or system type. So I posted yesterday about the toggle system basically incorporating a U channel within the space secondary ceiling cavity so that
Right.
you can avoid doing structural glazing. It's dictated in Germany, I guess. You know, I learned this from
Right. It's a
Spence and so
safety
forth
requirement in Germany.
for them. So, but I'm thinking like, well, wait a minute, maybe that actually makes sense from all of a sudden you're not relying on the QA/QC of structural silicone glazing in the shop or in the field. So maybe there's actually some merit to it. But someone chimes in and talks about how all of a sudden you're risking condensation now all around the perimeter of the IGU. And I'm like, gee, you're right. what you just so like when do we take the energy stuff so far that we're missing the bigger picture?
So we're letting the apps take over. We really are. And people are considering themselves professionals because they learned how to use an app. Most of the time the apps are free. And, you know, I I'm not saying we shouldn't, and I'm not saying they're not doing good work, but it's not real science. We call it building envelope science, but so much of it is apps. We're using this software, and again, I'll refer back to Joe. You know, we had common sense, we had empirical knowledge and empirical data that showed us things that's being overridden now by finite element analysis, but it's not finite element analysis. There's no way to ever get all the elements in that analysis. You think you have it, but you got to really dig through and figure it out. I think a big part of it is photographs versus video. So much of this software uses a photograph. It sets conditions and it says, oh, this is what you're going to have. How many seconds out of the year are you going to have that? It's literally sometimes seconds and minutes out of the 33 million seconds a year. You might have 300 that it reaches that point. And you shouldn't be designing based on that. You shouldn't be saying, I can only put 3 inches of insulation on that foundation wall because it shows on my woofy analysis that it's going to get condensation. When? When? And even what we do is not capturing everything, right? We're saying it's 72 degrees inside or 70 degrees inside and 30% relative humidity. Well, it's not. It's a living, every building is a very complex organism. It's a complex system. And we do the best we can. And we really need to fall back and look at what worked, not what the computer is going to tell us works. We need to know what works. And that's why having John Straub on, having Joe on, having a lot of the people on that I consider the people I learned from, and I'm glad they're still giving the knowledge to people of your generation, right? I'm an old guy, and they're older than me, but that's besides the point.
I'll say this, from my perspective, because I think what you try to do is share wisdom, but also acknowledge, a lot of your audience is the younger designers and the younger facade consultants and the younger contractors. So as much as you want to be like, you don't know what the hell you're talking about, you haven't been through it, you got to resonate with these people too, to some level. So, for
Yeah.
someone like me, who I'm not, call it where I want to be at technically, and I'm still trying to learn, you start to buy into some of this, woo-ha, maybe what you consider nonsense. You think like, oh, I got to start going down that path, or maybe there's some merit to it, or this is going to make me sound smart, or make me sound like I know what I'm talking about. So it's kind of hard to know what to and not to subscribe to.
The software is not bad. I don't want to seem like I'm, down on the software. Some of it is, but most of it's not when it's used correctly. Unfortunately, Europe's on one time scale and we're on a different one, right? We don't plan a building here for 10 years and build it in 4. That's what they do in the rest of the world for the most part, with a few, Tokyo's probably faster than we are, but they also don't build different. Everything's built the same in Tokyo. They know what works. They stick with what works. Um, but the rest of the world plans buildings for a decade and builds it in half a decade. We do the whole thing in 24 months. Once we have approvals from the city, it's off to the races. The clock's ticking, the interest is piling up. The owner wants it now. The GC can't get it now. The suppliers have, supply chain issues. All of that factors into how we do things. So we're looking for shortcuts to everything. And it's why we need a strong building code. And it's why people think the building code is too stringent, like the stretch code is too stringent. The reason why it's too stringent is because we can't look at things under a microscope all the time. So we shoot for this, expecting to get this. And
Yep.
that's what the stretch code is. They know if they ask for this, what they're really going to get is this, because there's no way to deliver it. There's not enough money in the world to make sure that every inch of that building, very few buildings are actually getting the oversight, inspections, and care that they deserve, right? We just can't do it. We don't have enough people trained. We don't have the time, and there's never the budget for it. You know, it was a few years ago, Cornell built a building, Cornell Tech, right? They committed to having Stephen Winters look at every inch of that building, every inch of that facade. They had full-time inspectors, not an inspector, inspectors on that job. How many buildings are willing to do that and make sure that when they put that building up, it's a legacy building? It's institutional clients are the only ones right now. Some institutional clients will do it. They're few and far between, even at that level, right? And I posted on LinkedIn the other day, we were tearing down a wall from a mock-up, and it was a six-inch filled CMU backup wall that the mason built. And it really, they're still loading trailers with garbage in the back of the backyard at the mock-up area. And why? Because those things stand up over time. They're resistant to, I'm not saying they're waterproof, but they resist leaks much better than lightweight framing and sheathing. Lightweight framing and sheathing is very good. It's very economical. It's light. It helps us reduce lots and lots of transportation and production costs, but you have to do it right. You have to make sure that the sheathing is fastened to the steel framing work correctly. The screws are not overdriven. They're on the correct spacing. You're using the correct screws. Then the air barrier, which we call it air barrier today, but it's the waterproofing layer, right? It has to be applied literally perfectly for it to be working perfectly. Every tenth of a percent that we reduce its perfection is potential for leaks, potential for air leakage or increase in air leakage. And, can we effectively build good buildings with it? 100% we can. Can we do it without properly scheduling, properly inspecting, properly designing those walls? No, because there's a trade-off. It's a lighter weight, lower cost system. You need to make sure that there's supervision and oversight, making sure that that system is being installed correctly.
When I was talking to you this morning, we were talking about a certain system, and I was talking to somebody else right before you about that same system, and the one guy's like, "Oh, people love it because of the quality," and you're like, "I don't know. We're gonna really find out how good that quality is." And it's such a strange, term for people to use, and define and throw out there. Uh,
I think
and
you're
it's
referring to prefabrication.
a prefabricated system.
So
Um,
it's great. It offers so much control in a factory. But again, do we do the R&D? Do we have proving grounds? Are people saying, I'm not just going to do a test to make sure I have a report that says, hey, it passed this? Are we going to test it all different ways? When you get a AMA 2605 finish on something, they put panels out in the sun in South Florida for years for it to be proven that it's going to not fade beyond what the manufacturer says it's going to do. Have any of the prefabrication guys, and I'm all for shop fabrication of walls, but have they really put that into it? The only industry that really has long track record right now is precast. We know how precast is going to perform as long as it's built right and installed correctly. We know it's concrete with reinforcing in it that's hung off the structure of the building. We've been doing that long enough. We know where the pitfalls are. Again, you had Joe on. He talked about the 3 line of sealant, defense, and precast joints. I love the concept. I don't see it actually being done too well in the real world, but that's that's just me. We
well,
have
let me ask you this. So a big theme this week at Glass Build, I think, was maybe not a theme, but what stood out to me was the automation in machine fabrication or frame fabrication, and how much of that we're seeing between glass cutting and processing and frame assembly. And so you're automating as much as you can in the factories just to either reduce man-hour labors or human error, or to compete with others. But how much of that is really being applied to the job sites? And so you can prefabricate a system and quote unquote control or improve the quality, but like what are the advancements you see on site? And is that the biggest detriment or pitfall?
I don't know if it's the biggest one. It's definitely one of the detriments and pitfalls. That system we were talking about relies on gaskets and field notching gaskets. I came up in the curtain wall business. That was one of the things. Every time we were designing a new system, we were like, we need to be able to eliminate any user error in the field on our primary seal. We need to make sure at the last curtain wall system that I was involved with the design on, we opted to field apply the chicken head gasket rather than shop setting them. Why? I was a big proponent of this. My mentor, a gentleman named Werner Cloak, who was our chief engineer, also agreed with me that we shouldn't preset the chicken head gasket. Why?
Because it could
Five
tear.
no, because 500 splices that they're doing on every floor. Every panel has to be spliced. The gasket has to be spliced
Is
into
that
the
what they
next
do
panel.
in Europe? If you see them go around the perimeter and lay out that gasket, is that what it is?
I don't know which
I
gasket.
don't know if it's commonplace for them to lay out the chicken head gasket around the perimeter um,
I think it
prior to
depends on
sending the units.
whose system it is, but a lot of Canadian systems are, because unitized curtain wall was born in Canada. People don't realize that. But a lot of the Canadian systems, like I was with a company called Fulton Windows that doesn't exist anymore. But our last unitized system, we used a top load chicken head gasket with multiple sealing surfaces. And that took us a year and a half to get right between the rubber manufacturer, our aluminum systems. It took us forever to get right. But think about it. We ran 500-foot rolls around the floor as because we always installed floor by floor because it doesn't work if you're going up elevations, it doesn't work. But on high rises, we're usually installing a full floor at a time with a leave out. We wanted as few splices of that primary seal as possible because it's your air seal, your water seal, it's everything. And we designed some secondary seals into our system that helped us. It was one of the has to happen things in the design of that system. I don't see that today. I see because people want to put everything they can in the shop, in the panel in the shop. Most unitized curtain wall we see is coming out with that chicken head gasket preloaded, and you're relying on someone literally to do that knitting and splicing detail at every panel, right? They're running they leave the gaskets 3 5 inches long on each end, and you've got to pull them back, trim them, put it into the next panel, do a little seal hopefully where the two gaskets come together, use the right seal, pray it's not raining when they did it, pray they didn't spill coffee on that crate when it was stored on the fourth floor that got full of crap that the iron workers says nah, it's fine, I'll spray a little alcohol on it. It'll clean it off. That's part of the tribal knowledge I talk about a lot. And that's why I really want people to take things slowly and see how the new technology works before they commit to 500 buildings with it before any of them are even installed. I mean, we have that going on right now. We're on jobs where it's a brand new system. We're doing the first major job, and there's 5 other jobs that have already been awarded to this company before they really have any on the wall for any period of time, which I they they may have it all right. They may have figured it all out. I'm not saying they didn't. I'm just saying, is it sensible to run before you can walk? And I think that's we have the same thing all over. Electrification is a big thing right now. I'm I'm an electric guy. I owned a hybrid car very early on. Toyota first came out with the hybrids. I was, first generation Camry. I bought a Camry hybrid. Everybody thought I was crazy. I said, well, I trust Toyota. I drive one now, but I think electric is the future. It's not the future in 3 years. It's the future in 30 years. We need the infrastructure. We still have a lot of work to do on batteries. We we can't electrify buildings that aren't ready to be electrified. NYCHA, our housing authority here in New York City, the New York City Housing Authority, is electrifying buildings right now. They're converting, again, fossil fuel heat. It's being ripped out of buildings and they're putting heat pumps in windows. Sounds great until there's a, you know, until there's a power outage. What happens? You can have a backup generator that'll run the main plant, the boiler, and it'll still distribute heat throughout the building. You're not going to be able to have a backup generator that runs 6,000 heat pumps in a building. There's one in every room. How many rooms are in a 100 unit building? 500 heat pumps? Good luck trying to do that on generator power. It's not going to happen.
When you're talking about people not, walking before they run, and talking about how, systems are getting by with a piece of paper or a test report, and people don't really know exactly what they're looking at. I'm kind of experiencing this right now, and it's really nice reflecting, even though when you lose a job in the moment, it hurts. It's good to understand, why that happened and what the psychology is behind decision making. And there's a window job that we pursued, and the competition came in at, not the material, the installed price came in at 50% lower. And we found out it's a, not even in this market, call it, it's in a union labor rate market.
Okay.
And no name glazing contractor, fine. My suspicion is that maybe they had some site logistical misses or errors, or assumptions, or didn't really do their due diligence on how they're actually going to remove and install these units in an occupied condo. I was told it was all in the material price. So this is a $1 million window job, and the number was off by 2 million. So right, you like, it's not even, 10%. All right, whatever the case might be. So very pretty strict facade consultant on the job. Very, I'm sure you know who, and it's difficult to get things past them or through. And this is an unknown manufacturer from a country in Asia. I don't want to name any specifics. Nobody's ever heard of them. And the condo board is saying, or the condo representative who was speaking to us said, I don't really know what to say. I mean, everybody's saying it's a equivalent product. We have test reports, and you don't really know what you're getting. But like, remove, five rungs from my brain, however many from yours, and just a lay person who doesn't know anything about facades, let alone fenestration, gets a test report and says, we'll give you your warranty, we can meet your specs, we'll stamp it and stamp by it. People don't know what they're looking at half the time.
So this week was NGA, the glass build show. 2 weeks ago was FGIA's fall conference, I guess it was. And I blame the industry. I blame the industry because, and this is back to what we always talk about, imports versus domestic. And we have a certain level of quality that for years, decades we had, and it was a certification program. The building code requires you to buy labeled and listed products, whether it's windows, whatever you're buying. Most building codes say you have to have a labeled and listed product. And labeled means it's approved by some certification program, right? That you have a known entity that's trusted that says this product meets all the requirements of our certification program and the building code, right? It doesn't get enforced. People don't understand. And why doesn't it get enforced? Because the building code officials are just like everyone else. Time goes by and people with the knowledge and the experience retire. They don't necessarily have the ability to pass on the knowledge and the experience by word of mouth. The training, we rely on training from organizations and companies, and the organizations aren't doing a good enough job of training the people who are there to safeguard the consumer, to safeguard the people living in those buildings, to say, no, that's not the equivalent of this. That is the minimum test that you can do to say it happened. And it monitored by a third party, an independent third party, or did they give you the what we call the short form test report that doesn't include all the retests they did, right? Do you want to see, they're just looking at the results and they're not looking at how they got to that past 12 PSF water test. Well, it took them 60 tries to get to it. And it happens. It happens. And again, I blame it on the industry, and I've been doing this for years, and I'm not popular with a lot of people at those organizations, but it's self-preservation. If you don't get out there and make sure that you educate the people who are responsible for saying, I want to see that certification label, I want to see a certified report. If they're not doing it, what's that mean for your members in the future? It means you don't have to worry about doing any more testing because someone's going to come in from Europe, Asia, wherever, and they're going to eat your lunch. They're doing it right now. It's happening in New York, Boston, a couple other places. Not as much in Boston as New York, obviously, but it's happening everywhere. And people are asleep at the wheel over this because it will affect domestic manufacturing. We need more engineering, not less. We don't need to lose the best the best fenestration engineering supplier that existed in the United States. We don't need to hear last year or the year before, whatever it was, we're getting out of the engineered products business. We need them to build the engineering products business. We need more engineered products because you know what? Photocopies of photocopies of photocopies fade after a while and nobody knows. You worked at a company that I worked at that used to be called Israel Berger and Associates, and unitized curtain wall was kind of new back when I was there. And I remember asking all the engineers, so how do you evaluate a unitized curtain wall that's 1/3 above the slab, 2/3 below the slab, blah, blah, blah. And everyone said the same thing. It's a simple beam. And I said, okay, you can evaluate it as a simple beam. There's some shear transfer at the stack joint, blah, 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 if they do it correctly. I said, but you got to make some modifications to a beam calculation on it because I don't think it's all transferred, but it's not. It's a cantilevered beam. 1/3 above, 2/3 below, it's a cantilevered beam. You have to evaluate it as a cantilevered beam. And it actually benefits the system, right? Because you don't have a very long span. You have two shorter spans, and the deflection is going to be a lot lower. Stress may be a different story, but the deflection is going to be a lot lower. And you don't have to use a 9-inch mullion. You can get away with a 7-inch mullion. And the people who actually knew what they were doing knew that and could prove it out, right? Physically by testing and through calculations. How many people know that today? They don't. I never see calculations done right on unitized curtain wall anymore. We do a lot of embed testing. I have a piece of steel on my desk that I had to draw so that we could put together a custom bracket for a job. And you know what? I look at similar jobs, basically the same size 5x10 panels, basically the same wind loads. Loads are 40%, 50% more on one job than the other. And I'm saying, how do we get to that? What are they doing that one job is a 12,000 pound shear load and one's 4? It just doesn't make any sense. It really, really doesn't make any sense. But again, standardization. We need more engineering. We need the organizations that are out there to protect the manufacturers and protect the consumers to stand up and put more education, put more standards online. Forget about editorial changes. I don't want to waste my time on editorial changes. Pay somebody to read and do the paragraphs correctly, or put the parentheses, or change we to thou or they, whatever. But, we need more people doing the hard work. And yeah, I'm going to be gone eventually. The other guys who are my age are going to be gone, and we need young people to start stepping up.
Oh, that was awesome. I got so many clips coming of you. Thank you for thanks for coming on. This is a lot of fun.
Good. I hope it was good.
All right, we'll talk soon, Eliot.
Thanks, guys.